Alright, we're taking a look at question 3.2c. It says a ball is being launched at 70 degrees with the initial velocity of 10 times 10 to the second. Oh, that's my code, so it's about 1,000. Oh, it is 1,000. This resultant here, we're going to have to break up into a horizontal and a vertical component. So what we need to do is take this this VI here, and break it up into its horizontal and its vertical components, VIY and its VIX. So if we take a look here, we have a right triangle. Here are the two components, and that's 1,000, that's 70 degrees. Now, here it is, and use a tip the tail method and make ourselves a nice right triangle. So VIY, set it up here. Just used some Soapatella. Now for the VIY, make sure your calculator is in degree mode. And we'll do just sine 70, times that by 1,000. And then cosine 70, times that by 1,000. Alright, so those are our two initial velocities right here. So that's VIY and that's VIX. So we have, this is 342.02, and I'll store this as alpha A actually. And then this one is 939.6 ... and I'll store that as alpha B. Alright, so I got it stored as alpha A and alpha B. So for VIY, we have, it's alpha B, and this is alpha A. Now, there's a bunch of other givens here that we know. So the acceleration for vertical is going to be negative 9.8, and for AX, it's going to be 0 because there's no friction in these problems unless otherwise stated. A couple things that we do know. The VY at the top is going to be equal to 0, and the VIX is going to be the same because it's just going to be alpha A. And the VIY is going to be equal to negative alpha B, because on the way back down, it's a symmetrical parabola, so the vertical speed going up is going to be equal to the vertical speed coming back down, or vertical velocity coming back down. So the first problem asks us to solve for the horizontal distance, it says the total range. So we want to figure out the total horizontal distance this way. So in order to do that, we're going to do step A. Number 1, part A, step number 1, we're trying to solve for dx, total. Step 2, our givens are, we have VIX and AX. Step 3, the only equation that we can use for the horizontal is dx is equal to VIXT plus 1/2 AT squared. This gets canceled out because A is equal to 0, but we don't know time. So dx is equal to alpha A times blank. That's going to be a bypass. Now, in order to figure out the time is the only variable that can be used in both the x and the y column. So step number 1, we're trying to solve for time. Step 2, the best one to use for solving for time is usually the vertical column. So I'm going to use the vertical column. I know VIY, VFY, and AY. So I'm going to do VF y is equal to VIY plus AY times T. So we have, this is going to be negative alpha B plus negative 9.8 T. T comes out to be, let's take this. Take alpha B, and we'll make that negative. And then we'll bring over alpha B. So then when we bring over the alpha B, it'll become negative. So it's basically taking this answer and adding another negative alpha B. So when you bring it over, see this alpha B here, bring it over the equal sign, it's like basically just 2 times negative alpha B. And so we take this answer here, and we divide it by negative 9.8, we get 100. So I'm going to store this as alpha C. This goes here. We take our answer here, take alpha A multiplied by alpha C. So we get alpha A times alpha C. That's our total horizontal distance a lot, but it works out. So we get about 65590. And our time now, we have that as alpha C, so we can add that there. And we also have dx is equal to 65590.